So this solar panel, it will charge this 9-volt battery, powers a pump that's down here. We took the pump from a squirt gun.
From where?
From a squirt gun, water gun.
Okay, okay.
Yeah. Um,
Alright, so the way the solar panel works is it will collect electromagnetic waves, which will knock out loose electrons in the cells within the solar panel and create an electronic flow.
The battery is chemical energy, so it charges up. It's got I forget exactly aqua, say it, but it holds the electrons and then converts it to electrical energy that is then switched to mechanical in the motor that powers the pump. The pump is it's an electric motor with a fan, and the blades, they're angled so that the water, when it goes in, gets kind of sucked through another fan that shoots it up. Just straw.
Okay.
We built a solar dehydrator. This is the box that all the food goes in, and it opens. And there should be trays in here. And then this is kind of the important part that does all the dehydrating. And so we made it out of soda cans. What I did is I just took these 2x4s and I kind of put them together, and I put holes in the top and the bottom. To put the cans together, I had to cut out the bottoms, which is kind of difficult. And so what I did is I took a file and I made a hole in the bottom of the can. And so then I just used garden trimmer thingies to clip out the bottom. And then the top, I pulled out the tab, or we pulled out the tabs. And then we would take the trimmers again and we would make little slits in the top of the can. And then it would bend them to kind of make fins to direct the heat up. And so I painted it all matte black because it absorbs the heat. And to seal it, I used this construction adhesive, and I would just put it on there, and then I used my finger and I would spread it out and stuff. And I did it in the bottoms and on the bottom of the cans too, so it just sealed the heat. So it goes in, and what the air does is the air will come through the bottom, and it goes through the cans, and it gets warmer or something, and then it gets inside, and then it does the convection thing, and it warms everything up and dehydrates it. And I haven't used it yet, so I don't know how hot it gets, but apparently it's supposed to keep really
So basically, it's a box inside of another box, and in between the boxes is insulation. The yellow foam that's inside of couches and stuff. We had an old couch in my garage, and we just shoved it down in there. And then this part is a painting. What do you call them?
The glass is from a picture frame. Fusion in the sun is a very, very violent process. All the particles are moving around very quickly. And as a general principle, whenever a charged particle accelerates, it gives off radiation. Likewise, when a charged particle absorbs radiation, it accelerates, and that's why sunlight is warm. So the sunlight comes in through here. The glass has another property that's useful, and that's that when the air inside of there it heats up, it wants to rise and it wants to leave the box, but the glass stops that from happening. Then a process of convection starts happening. The hot air rises, and then it falls, and it gets hotter and hotter, but it's trapped, and so you have a greenhouse effect that way. And so visible light, glass, is a perfect material because it's made to be transparent to visible light, and so it comes in, and the radiation is absorbed by the molecules in the food, and they begin to accelerate and get faster and faster, and all this kinetic energy beats apart the molecules and denaturizes the proteins and makes a chemical reaction that we call cooking.
We'll start with materials. So we have mylar, which is this red stuff, and the silver reflective stuff inside. It was used for old rear projection TVs, which would project the image onto the fabric and then bounce onto the screen because it would flip it, and then you can actually see. But it's really reflective, so we use it for that. And way we got the mylar, because they don't sell it in sheets anymore because they don't actually make those TVs. They sell them in balloons. So we bought a bunch of balloons and cut them up. And so
you guys, it took forever. Recommendations that we have is when you begin actually
make, like if you're gonna make a plan, follow through with your plan, because we cut like our base and everything and we built it, and then, because our original plan, it was gonna be kind of in like a flower shape, but once we cut everything, we figured that it would be really hard now since our base wasn't like circular. So, and then also get wood that's a bit thicker so you can actually nail through in that part.
Not stab
And
yourself.
on the inside, we have a metal plate, and that's it. We spray painted that black so that it could absorb a lot of heat. And then there's styrofoam with foil on the outside of it so that it'll attract the sunlight and keep the heat in. And we have a door back here, and that has foil and styrofoam on it as well. And then we have this little piece right here so that the heat doesn't get out. This is just like, okay, so this is real glass.
Sun radiates through the glass.
And it's
And-
refracted
yeah.
in glass.
Yeah, and then the insulators help keep the heat in. And then as it heat ups the metal, it cooks the food through conduction.
Because they're touching.
Yes.
So it's not, I mean, it's wood, but it's like ground up wood, so like they recycled it. And so like it's
From, like, an old
really, really old shelf that we used to have. We didn't have a power saw, we just had a like normal saw. So, and it was rusty too, like it wasn't sharp. It was not even.
We spent like hours cutting.
It took us so long to cut this wood and like have it the right shape. And then the reason this is here is just because we got tired of cutting.
We would have
There's
cut.
no
It would have been
purpose.
smaller, but then
Yeah.
we just like, oh.
Sun has its rays and it hits this glass. And then, because it's black, it goes and it attracts it.
The heat waves that travel through the foil, because the foil makes the rays bounce off of each other, and it can hit the, say we have the chicken in there, it can hit the chicken in different spots to heat it up. Kind of like a microwave, but it's not really a
And
microwave.
then it's also insulated to help trap heat inside.
We used wood,
You use wood?
styrofoam, and foil.
This is our solar oven. It's little so that more heat will collect faster because it's smaller. It's slanted so that the UV rays that are electromagnetic from the sun will come in and reflect off of the tinfoil because it's a shiny white surface. And then it convects the heat inside of the oven, and like the heat raises through a raise in kinetic energy because heat is a change in temperature, which is also in turn kinetic energy.
This is plywood. It's just like simple plywood from Lowe's Goods, but plywood is a good insulator. And then this is composite wood, so it's very compact and it insulates well. Just because the process is they take wood and they grind it up and then they pack it together really, really tight. So this doesn't let very much heat out, so that's why we picked this wood for the base and then these two sides. And then inside we have the same foam that they had. It's just regular styrofoam, but it's covered on both sides with reflective, whatever this is called, tinfoil. So it keeps the heat in, and then it also reflects the radiation around where it can heat up. The door is made out of all the same materials. We just cut it out. And the reason we use liquid nails instead of caulk, which is the main questions, is liquid nails is more, it doesn't really dry. Like if you want to touch this, it's like kind of mushy, and it doesn't dry, so stuff that dries eventually gets cracks, and since it doesn't really dry, it will just keep filling holes and just keep sealing it. This is plexiglass.
First we had a big box, and we put a smaller box in the bigger box, and we stuffed it with newspapers and college letters that I'm never gonna read, and like magazines and catalogs and pieces of styrofoam for insulation. We put foil inside the smaller box so that the heat can like reflect off and cook the food that's gonna be inside. We made a solar oven.
Yep. And we put the door in the bags right there.
And then this is plexiglass.
And then, yeah, my little brother helped me build it. he cut all the boards and everything, and
We all had a fun time
oh yeah.
caulking it.
It has 2 layers of insulation on the inside, and then another board, like another boards, and then some foil, and we stapled that to the board. And
It was hard work. It really was.
the only reason my little brother helped me is because he had to do a science project too, and he did a poster over a solar oven, so
So it was
2 in 1.
perfect.
Creates electromagnetic waves, and it bounces off all the foil, and it comes in there, and it conducts heat, and it makes the particles hotter, and it makes them move faster, so they get hotter, and then cooks the food. So
The sun
the
comes
sun
out.
comes up, yeah, and then it shines through here, and it creates electromagnetic waves, and then it bounces off all the foil and everything. And then the bottom of it with the black mat, where it's not covered in foil, it absorbs the heat and the light, and it keeps it trapped in there, and then it slowly cooks the food that's sitting in there.
Well, it's not necessarily like natural, but it's pretty natural because you don't have like gas heating it up like a normal oven or like electricity. You just use like solar energy.
And it has like the electromagnetic waves going in
Yeah.
there.
So let's say like your power's out, you can just use this to cook some bacon or something.
Bacon.